Hi, I'm Ryan, and today I'm going to show you how to find the nth term of a sequence when the description of the sequence is given. And those sequences would be arithmetic and geometric sequences. Some key vocab terms you might need to know is geometric sequence, a sequence in which the ratio of any term to the previous term is constant. Arithmetic sequence, a sequence in which the difference of consecutive terms is constant. A common ratio, which goes with geometric sequences. A constant ratio from any term to the previous term. Common difference, which goes with arithmetic sequences, is the constant difference between terms. An arithmetic series, which is the expression formed by adding the terms of an arithmetic sequence. And a geometric series, which is the expression formed by adding the terms of a geometric sequence. And here's a little cool comic that I found, which explains arithmetic sequences a little bit. And a couple ways to help you remember about geometric and arithmetic sequences is that when you see the words ratio, multiply, or divide, those usually point to a geometric sequence. And when you see the words add, subtract, or difference, those usually point to an arithmetic sequence. And for the formulas, those are given to you on the SOL formula sheet, so you don't need to worry about remembering those. And here are your two geometric formulas and your two arithmetic formulas. Now for the first problem. What is the seventh term of the geometric sequence with a first term of 729 and a common ratio of 1/3? So we have our formula here, and AN would be 7 because that's the number of the term you're trying to find. A1 would be 729 because that's the first term in the sequence, and R, which is the ratio, would be 1/3, which was given to you. So you set up your equation, A7 equals 729 times 1/3 to the 7 minus 1 power. You would simplify that, and A7 equals 729 times 1/3 to the 6th power, and 1/3 to the 6th power is equal to 1 over 729. So when you multiply that by 729, you get A7 equals 1, or the 7th term equals 1. For the second problem, the real-world application problem, John received $1 on his first birthday from his grandparents, who agreed to double the amount with each consecutive birthday. If his parents hold up to their agreement, what amount will John receive on his 20th birthday? So you have our formula, and this will also be a geometric sequence. The number of the term you're trying to find is 20, so AN would equal 20. Your first term is 1 because that's what he receives for his first birthday, and the ratio, or R, would equal 2 because he's doubling it every year. So plug those into your equation and you get A20 equals 1 times 2 to the 20 minus 1 power. You simplify that into 2 to the 19th power and then multiply that by 1, and you get, or don't multiply it yet, simplify 2 to the 19th power and you get 524,288, and then multiplied by 1, you would get the same thing. The 20th term equals 524,288. And for the high-level assessment question, or the question that's most like something you would see on the SOL, find the 16th term in the sequence. 3, 9, 15, 21. AN would equal 16 because that's the number of the term you're trying to find. A1 would equal 3 because that's the first term in your sequence, and D would equal 6 because that's the common difference. You plug those into your formula and you get A16 equals 3 plus, in parentheses, 16 minus 1 times 6. Remember PEMDAS, so you would simplify what's in parentheses first. You get A16 equals 3 plus 15 times 6. And remember PEMDAS again, you would multiply before you add. So multiply 15 and 6, and you get A16 equals 3 plus 90. You simplify by adding 3 and 90, and you get the 16th term equals 93.